So it says determine which are functions and which have inverses. Okay, so for letter A to determine if it's a function, then we can just use the vertical line test. So if you draw a vertical line anywhere, notice that the graph only touches in one location, and so that's going to be a function. Does it have an inverse? In order to have an inverse, number one, it has to be a function. Okay. If it's not a function, then it's not going to have an inverse. So since this is a function, the way we check for inverse is there's another test, which is a horizontal line test. So what that one says is if you draw a horizontal line and it only crosses in one spot, then it's going to have an inverse. Okay, so this one will have an inverse. And then for letter B, is this a function? So again, we can draw a vertical line test. Since it touches in two places, then this is not a function. Since it's not a function, then it's not going to have an inverse. Okay, so I'm going to put here no inverse. No inverse. Here's a circle. So if we look at the circle, then we can see that the circle, if you draw the vertical line test, is not going to pass, so this is not a function. Since it has no function, or it's not a function, then it has no inverse. So if you look at that second one, if you had drawn the the horizontal line test on letter B, it would pass it, but it's still no inverse because it's not a function. For letter D, it says, is this a function? Okay, so since the square root is already here, then your graph, the parent function looks something like this. Okay, but this would be a function, right? If you draw a vertical line test, if you draw a horizontal line test, it's going to have an inverse. Since it has a square root there, then we can say that this is a function because no matter what value you put in for x, you're always going to get one value for y. Okay? So this will have an inverse. And then for the next one, y equals x squared minus 4. If you think about the graph, it looks something like this. So that would pass the horizontal line test. So this would be a function. But does that pass horizontal line test? So we draw a horizontal line, then it's going to fail the test. So this is going to be no inverse. So although it's a function, it doesn't mean that it has an inverse. And then the last one, since the x is squared and the y is squared, then that means that this is a circle. And this is definitely not a function. That means it has no inverse. Determine whether the function has an inverse. Okay, so if you look at the function, what kind of graph is that? Is that a circle, a parabola, a line, a square root? It's a line, right? How do we know? Because the exponent for x is 1. So since it's a line, something like this, then that means that it's a function and it should have an inverse. Okay, so how do we find the inverse? The first thing that I like to do is write down the problem. And then your first step when you're finding the inverse is to change f of x to y. That's your first step. Okay. And then your second step is we're going to switch the x and the y. So instead of y here, I'm going to write x is equal to 5y plus 6. So we just switch them. And then the third step is to solve for y. So we're going to subtract the 6. So we get 5y is equal to x minus 6. We still need to solve for y, so I'm going to divide by 5. So y is equal to 1/5 x minus 6/5. So your final answer here is going to be f inverse of x is equal to 1/5 x minus 6/5. Let's go to number 3. So for number 3, we have the compositions. So whenever you see that symbol, that means composition. Okay, not multiplication, but composition. So what does composition mean? Anytime you see this, usually we have an X here, but if you don't see it, it's okay. This just means f of g of x. And so basically, the second function that you see here, the g, is going to go inside of the parentheses. Okay. And then we work it out. So we have f. G of x is x minus 4. So I'm going to replace my g of x with x minus 4. And then the x minus 4 is going to be substituted into x in the function f. Okay. So wherever f is, here's my f. So wherever you see an x, we're going to replace it with x minus 4. Okay, so this is going to be equal to, I have an x squared here, so I'm going to have x minus 4 squared. Why? Because I took everything that's in the parentheses here, and I substituted it in for x. And then you want to multiply this out. So this is the same as x minus 4 times x minus 4. Multiply it out. So we get x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. Negative times negative is a positive 16. Gather your like terms. So your composition is equal to x squared minus 8x plus 16. G composed of f. So again, if it helps, rewrite this the way it's defined. This is the same as g of f of x. So now notice that the f of x is inside because it's the second function in this composition. So f of x is x squared. And if it helps, let me just move it up a little bit so we can see the equations. So f of x is x squared. So now whatever is in here, we're going to replace it in all the x's of the function g. So we're going to take this guy here. We're going to take this guy, and it's going to replace this x. Okay. So this is going to be equal to x squared minus 4. And then I can't simplify further, so my answer is x squared minus 4. We get g composed of g. That's the same as g of g of x. Okay. So inside, they want us to put g of x. So g of x, again, is x minus 4. And then I'm going to take whatever's in here, and I need to replace it in my x's, but for what function? For g, because it has the g in front, right? So we're going to take this and plug it in for my x. So this will give me x minus 4 and then minus 4. So my answer will be x minus 8. So find f of g and g of f. So for letter A, we do the same thing. So I'm going to rewrite this as f of g of x. So that's going to be f of g of x. G of x is x squared. I have f of x squared, so this x squared is going to have to be replacing the x for the function f. Okay, so this is going to be equal to the square root of x squared plus 2. So my composition, f composed of g of x, is just equal to the square root of x squared plus 2. I cannot simplify inside because I'm adding x squared and the 2, I'm adding them together, so I cannot break it apart. Okay. If x squared was by itself, then I could simplify the square root of x squared. G composed of f is the same as g of f of x. So that would be g of square root of x plus 2. So what do I do with the square root of x plus 2? Do I plug it in for this x for the f? Or do I need to plug it in for the x over here with the g? With the g. Okay, so this is going to be equal to square root of x plus 2. That's replacing my x, but it's squared. Okay. So now anytime you have a square root and it's to the power of 2, then the square root and the 2 become a 1. So we just say that they cancel, but it becomes a 1. Okay. So this is equal to, so basically that becomes 1 or it cancels. So we get x plus 2. So then the domain, it says what is the domain of f? So the domain of f, so basically that's all the numbers that you can use for x and still get an answer back, okay? So if I had like a negative 4, then I couldn't use negative 4 because we would have a negative 2 left over inside the square root, and we can have a negative in the square root, okay? So we need to find those values. So the way to find it is we take the radicand, which is whatever's inside, and we set it greater than or equal to 0, okay? And then we solve for x. So x is greater than or equal to negative 2. So at that point, that's where you begin your domain. So anything from negative 2 to the right is going to be a good number to use, okay? And it's included in the domain. So the way we write this is going from negative 2 to infinity. And notice I use a bracket because I have the greater than or equal to sign. The domain of g, so the function g is x squared. Okay, so do I have any fractions here? No. Do I have a square root? No. So my domain is going to be negative infinity to positive infinity. Because it's a parabola and it uses all your x's. So my domain is negative infinity to positive infinity. The reason we're doing individually f and individually g is because in order to do the domain of the composition, you have to look at these individually as well, okay? So to find the domain of f of g, the second equation, in this case is g, you have to consider that domain, okay? So I'm gonna write here domain of g is negative infinity to positive infinity. And now the composition of f of g of f composed of g, our answer to that was, this was our answer, right? So here, do we have a square root? Yes, so that means that there might be some numbers that we cannot use, okay? So we would set, but then notice that we run into this issue here, okay? So the way we can think of this here is that the x is squared. So if you put a negative number for x, is it gonna come out positive? So if I put a negative 3 here, negative 3 squared is 9, plus 2 is gonna be a positive number. So no matter what I use for x, I'm always gonna get a number that is positive. So in this situation, even though it has a square root, I'm gonna say my domain is still negative infinity to positive infinity because of this x squared. So notice I'm doing the domain of g by itself, and then I'm doing the domain of f of g, okay? Now your final answer is, what does this and this have in common? Everything, right? Because it's the same thing. So your final answer for the domain is going to be negative infinity to positive infinity. Sometimes that's not the case, which we'll see right now in the next one. So for the next one, domain of g of f, since f is the second function, then that's the one that we're going to look at by itself. So I'm going to write here domain of f, and I think we said it was from, what was that, -2 to infinity. And then we're going to look at the domain of g composed of f, and then that equation was, I don't remember, let me check. What was it? Oops, this is like so sensitive. X plus 2? Okay. So we're looking at x plus 2. Okay. Well, is there any fractions for the x plus 2? No. Is there any square roots? No. This is a line, so that means that the domain for this is negative infinity to positive infinity. So now you need to ask yourself, what does negative infinity to positive infinity have in common with -2 to infinity? Infinity for sure, and what else? -2 on, right? So you can also draw yourself a little number line if it helps. This is -2, 0, and so on. And so for the first one, this was all my domain. For the second one, it's everything here. So what do they have in common? Just from where you see the red and the green, so this area. So your answer is going to be from -2 to infinity. Okay, then we go on to the ones where we have to add and subtract, multiply, divide. So whenever you see something like this, then the first thing I encourage you to do is to separate it the way it's defined. So f plus g of x is just equal to f of x plus g of x. And then we substitute our values. F of x is x plus 6, right? That's what they tell me here. And g of x is x minus 6. Gather your like terms. So we have an x plus an x is a 2x, and a 6 minus 6 is a 0, right? So my answer is 2x. Okay. And then subtracting, same thing. I'm going to do it a little bit to the left so it doesn't look too crowded. So this is f of x minus g of x. F of x again is x plus 6 minus g of x. What is g of x? X minus 6. But here you have to be careful and always use parentheses, because if you don't use the parentheses, then it's going to, you might make an error. Okay. Since I have the parentheses, I'm going to distribute the negative in here, so I get negative x and a positive 6. Gather your like terms. X minus x is 0, and 6 plus 6 is 12. So my answer is 12. So here we have f of x times g of x. So sometimes instead of the way it's written here, they might say this, okay, f times g. So don't get it confused with this one, because they mean different things, right? This is composition, multiplication. All right, So here we're going to end up with f of x, which is x plus 6, and g is x minus 6. So we're going to multiply. X times x is x squared. X times negative 6, negative 6x. 6 times x, positive 6x. 6 times negative 6, negative 36. Combine your like terms, so we get x squared. Negative 6x plus 6x is 0. So we're left with negative 36. Question on that one? Okay. Letter D, let me write it over here. So this is division. So I can write it like this. And then f of x is x plus 6 divided by x minus 6. And I cannot simplify this any further, right? I cannot cross out the x's because they're attached to that plus 6 and that negative 6. Okay. If it was like this, then yes, you could cross out the whole thing. Okay. But since one's positive, one's negative, then they're not the same. Letter E, find the domain. So since your domain, we ask ourselves, do we have any fractions? Yes. Okay. So here, we need to get rid of any numbers that cause you to have a 0 in the denominator. Okay. So for, some of you might be able to see what that number is. If you're not sure, it's okay. What we do is take the denominator and set it equal to greater. So if I add 6 on both sides, then I get x is equal to 6. So this number is not included in the domain. Why? Because if you put a 6 here, you would end up with 6 minus 6, which is 0. And we can divide by 0. Okay. So my domain is everything except for 6. So how do I write that? Everything except for 6. Can I use the negative numbers? Yes. All the way to 6. And I'm going to use a parentheses because I do not want to include it. Right? And then I'm also going to include everything that's bigger than 6. So if you were looking at a number line, because I like number lines, because sometimes it makes it easier to write your interval notation. So your domain is everything, all of these numbers, except for this number. Okay. So this is negative infinity and this is positive infinity. So that was letter E. For 6, I'm going to set it up for you, but then I'll let you work it out. Okay. So F composed of G is the same as, we're multiplying this, right? So what are we going to do with this 8? So this is the same as f of 8 times g of 8. So there's actually 2 ways you could do this. If you didn't have an 8 and it was an x, then you would have f of x times g of x, right? But since we have an 8, we can just work it out with an 8. This here, without the 8, would mean that you would have to multiply all of this stuff and then get an answer, right? And then once you get an answer, then you plug in the 8. That's one way to do it. But over here, we can just work with each function individually. F of 8 means that wherever I see an x, I'm going to plug in an 8 for that function. So here I would get 8 plus 3, and that's for my f of 8. And then for the g, I'm going to plug in this 8, and for my g here, so I get 8 squared minus 2. 8 plus 3 is 11. And then 8 squared is 64 minus 2, 62. 11 times 62 is 682. So if you were to multiply all of this out, you get x cubed plus x cubed minus 2x plus 3x squared minus 6. If you plug in the 8 for all your x's here, then you should end up with 682. Okay. But you don't have to worry about the right side here. If you did it the left side, then that's good. Okay. Any questions on 6? Okay, then we get to graph number 7. So it says sketch the graph of the function. So this is a piecewise function. Okay. So one of the first things that we can do is decide if when you graph it, the point, is it going to be an open point or a closed point? Since I have a less than or equal to sign here, I'm going to have a closed dot. So I always like to write it there so I can remember. And then for this one, since it has just a greater sign, I'm going to have an open dot. Okay. And then what I like to do is separate my equations. And I'm going to use this point plotting method to graph it. And normally for x, I would choose whatever I want. Okay. But for these, they're specific on the values of x that they want you to use. So they're saying for x plus 5, use values that are less than or equal to negative 3. So what are some values less than or equal to negative 3? Negative 4 and negative 5? Anything to the left of it, right? So remember, always if you feel like you need to visually see it, then anything less than negative 3 is going to be these numbers to the left. So how do we work this out? If I plug in 5 for x, then I get negative 5 plus 5, which is 0. If I plug in a negative 4, negative 4 plus 5 is 1. And g of negative 3 is equal to 2. Okay, then we also need to do the second equation, right? Let me make it in black. You can plot the red one already, but I'm going to go ahead and do the black. So here it's saying use numbers that are greater than negative 3. So what is greater than negative 3? What about this point? Is that greater than negative 3? This one here in the black. Yes, right, since it's to the right. And then this is greater than negative 3. All of these are greater than negative 3. So to include those, I'm going to use negative 3 here. But when I graph it, I use the open circle to know that I'm not using negative 3, just everything close to it. Okay, so let's do the work. G of negative 3 is equal to 1/2 times negative 3 minus 7. Negative 3/2 minus 7. Go ahead and use common denominator. So this 7 has a 1 below it. In order to make that 1 a 2, I have to multiply it by 2 over 2. So that's 14 here. So I get negative 17/2. If you plug in a negative 2, that makes it easier because negative 2 1/2 times negative 2 is negative 1 minus 7. So that's negative 8. And how many points do you really need for a line? This is a line, right? You just need 2 points at least, which we already have. If x is 0, then we get a negative 7. So we get negative 1/2 minus 7. We need a common denominator. So that's 14. 14 divided by 2 is 7. So that's going to give us a negative 15/2. Okay. So I have my table, which is what I need, and then I can graph this. Okay. So for the first one, g of x equals x plus 5 is right here. And then negative 5 and 0 is right here. Negative 2 and 3 is right here. And then negative 3 gives us a positive 2. But I'm going to use, what? I can't use negative 2, right? So let me erase negative 2. The reason I can't use that is because it's not less than negative 3. So for negative 3, we get 2. But remember I said we're going to use a closed dot. Okay. So that's going to go on forever, right? Anything less to the left. So if I draw my graph, that would be my graph. And then if you guys can tell me what numbers we used here. What was the first one? And that gave us a negative 17 halves. Like this. And then negative 2 was negative 8. And then we had negative 1. And 0 was, okay. For negative 3, remember we said an open circle, right? So at negative 3, here is going to be an open circle. And then negative 2 gives me a negative 8. Is right here. And then really I can just draw my line because it's a line. And you can plot the rest to this one. Consider the following: f of 1 is equal to 1, f of 0 is equal to 8. Write the linear function. So in order to write a function, you need to have a slope and you need to have a point, okay? So these values here just mean that x is a 1 and y is a 1, okay? And then this one means x is a 0 and that gives you an 8. So then from there we can find the slope, or you can plot those and find the slope, whichever way is easier for you. So 8 minus 1, 0 minus 1, 7 minus 1, negative 7. Is there anything special about 0, 8? Does anybody remember? So that's actually your y-intercept. So 8 here is your letter B. Okay, so because remember your equation is going to look like this. So you already know B, but let's say you forgot that 0, 8 is your B, then your next step would have been to plug it in here. So you can pick either point. So I'll pick this one here. Y minus 1 is equal to my slope. And then you would solve for y. So y is equal to negative 7x plus 8. So notice that 8 that we got. So my function here is my slope, which is negative 7, and my y-intercept, which is 8. Okay, so recognizing that since x is 0 here, that's going to be your y-intercept. Will save you time because you know that's the number that goes here. But let's say that you didn't have a 0 or you forgot about that, then your next step would have been to use the point slope form. Sketch the graph. You can use a table like we did up here, this one, or you can use the slope and the intercept. So 8, 6, 7, 8 is right here. And then the slope, I'm going to go down 7 and to the right 1. Okay. So 1, 2, 3, 4, 5, 6, 7. And then to the right 1. So remember your slope is -7. You can have a 1 under it. So you go down 7 to the right 1. Or you could have gone up 7 to the left 1. Because sometimes that happens on the computer, right? You don't have space to actually go down. So you might have to go up and then work it backwards. Okay, number 9 is, so now I'm getting to the earlier sections, right? So here all you have to do is plug in wherever you see a t, you're going to plug in a 2. 2 squared is 4 times 3 is 12. 4 times 2 is 8. 1 minus 8 is 4. Plus 5, 9. And the same for the next one. 3 times -1 squared minus 4 times -1 plus 5 is -1 squared is 1 times 3 is 3. And then -4 times -1 is a positive 4 plus 5. And then the last one, we're substituting t plus 2. So we have to expand this out, right? Multiply it. Distribute this 4. So multiply the parentheses. T times t is t squared. T times 2 is 2t. 2 times t is 2t. 2 times 2 is 4. -8 plus 5 is -3. 3 times t squared is 3t squared. 3 times 2t is 6t. 6t, and then 3 times 4 is 12. I forgot a plus sign here. Gather your like terms. 3t squared. 6t plus 6t is 12t. 12 minus 3 is 9. Okay, number 10. Find the equation of the line that passes through these points, parallel and perpendicular. So the first thing that you need is a slope, okay? So we're going to take our line, 8x minus 2y equals 9, and we need to find the slope. So I get -2y is equal to -8x plus 9, divided by a -2. So y is equal to 4x minus 9/2. So the slope of that line is 4. So now for parallel, you want to ask yourself, if it's parallel, do I use the same slope or is it going to be different? So parallel lines have the same slope. So I'm going to write here, we're going to have m is equal to 4, and then we're going to use the point that they give you, 4, 1. So at this point, you can do 2 ways, right? And I think on my videos, I show you both ways. You can use the point slope, or you can use y equals mx plus b, whichever way you feel more comfortable with. So y minus 1, remember this is your x and your y. M is 4, x1 is 4. Simplify, 4x minus 16. Add the 1, so what do we get? 4x minus 15. If you want to use the second way, then this is what it would look like. Your y here is 1, your slope is 4, your x is 4, and so you're just solving for, and then you would plug it in. Okay, so either way is okay. For perpendicular, then we have to get the negative reciprocal of each other. So instead of m equals 4, we're going to take the negative reciprocal. So here's negative, and then the reciprocal of 4 is 1/4. And then from there, we would do the same steps. I'm just going to do it one way. So y minus y1, our slope, distribute the negative 4, negative times the negative 1/4 times the negative 4 is positive 1. At the 1, so we get y is equal to negative 1/4 x plus 1 is plus 2. Write the standard form of the equation. Okay, so the standard form. So you want to remember this formula, right? So for your center here, that's h, and this is k. So we just plug it in. Radius is 2. And then simplify as much as you can. So negative is positive. Okay, so for 12, it says find the center. So notice here that when it was a negative 7, we actually have a positive 7. It was a positive 9, we have a negative 9. So you can think of it that way. Since I have a negative here, then my center here is a positive 1. Since I have a positive, it's going to be negative. The radius in the equation, notice it has an r squared, right? So r squared is equal to 9 in this case. So we solve for r is equal to 3. It has a plus or minus 3, but the minus we don't use because we're talking about distance, okay? So your radius is 3. And then to graph on the computer, okay, what I do is I plot the center. The center is 1. This is my center. And from that point, I'm going to go up 3, down 3, left 3, right 3 to get the outers of the circle, right? So 1, 2, 3 would be here. And then 1, 2, 3 would be here. 1, 2, 3 would be here. And here. And then you would draw your circle.